Good day everyone. So today we're going to show you ways of solving a system of linear equations by elimination, by substitution, and by Cramer's rule. So are you excited about this? Let's see. Technique. Okay, so by elimination, what we want is to eliminate one variable at a time by adding or subtracting the given equations. And this can usually be done when one of the variables have same numerical coefficients or can be made to have same numerical coefficients using algebraic processes. By substitution, what we mean there is to express one variable in terms of the other and then, just like the name suggests, substituting this expression to the other equation. By Cramer's rule, what we want there is to use determinants to solve for the value of the variable. So here, we're going to recall the formula for the determinants. We're going to methods with the use of this example containing two variables x and y. So we're given with two equations, 2x plus 4y equals 13 and 6x minus y equals 0. As we know from our previous video, this is an example of a system which is consistent and independent. So we expect just one unique solution or one pair of x and y satisfying these two equations. Using elimination, what we want there is to eliminate one variable at a time. So between x and y, the more ideal variable to eliminate will be the y, since this has a coefficient of -1. We can just multiply that by 4 to arrive at 24x minus 4y equals 0. Okay, then we just have to copy the first equation. Yan. So with that, they have the same numerical coefficient though different in sign. That means we can just perform addition because this will cancel out. So adding the two equations, what we want there ideally is to align the variables or align the terms containing the same variables as well as the constants. Okay, so we have 26x and then equals 13 plus 0, which is just 13. Okay, so solving for x, we have 13 over 26 or simply 1/2. Okay, so now we are going to substitute this solved value of x to either of the two given equations. Say we are going to substitute it to the first equation. Okay, so the first equation is this. So if we are to substitute this to the x in here, we will have 2 times 1/2 plus 4y equals 13. You notice we can just cancel the 2's. Okay, so this will give us 1. These are reciprocals of each other. 2 times 1/2 is 1, not 0, huh? So that is 1, okay, plus 4y equals 13. So we can just move the 1 to the other side. Okay, that is by subtracting 1 on both sides. So we have 4y equals 12. Okay, with 4y equals 12, we can simply divide both sides by this numerical coefficient. This becomes the divisor of the variable we're solving for. So we want to get rid of this. So we have to we have to divide both sides by 4. Okay, so y will be equal to 12 over 4, which is 3. Therefore, we have our solution, which can be written as an ordered pair 1/2, 3. Now, using substitution, again, what we want is to express one variable in terms of the other. And the easier way is to make use of the second equation. Okay, so we can write that as 6x equals y. Okay, you can simply add y on both sides of this equation. Okay, adding y on both sides or simply moving the y to the other side. Okay, diba? By simply moving y to the other side, we just have 6x equals y or y equals 6x. Okay, now what we are going to do is substitute this to the y of the first equation. Okay, so that is our first equation. So what we want is to make this equal to 6x. Yeah, so that we just have one equation, which is just in terms of x. Just one equation in terms of just one variable, which we can now solve. So this is 24x, this part is 24x plus 2x, that gives us 26x. Since 26x equals 13, therefore x equals 13 over 26. Again, this coefficient becomes the divisor. Yan. We divide both sides by 26. So, what's 13 over 26 in simplest form? It's x equals 1 half. Okay. Now, you have 6x equals y. Now, to solve for y, you can just go back to that equation. So, we will just substitute 1 half to our x here, giving us 6 times 1 half, which is y. We can divide 6 by 2. Therefore, the answer will just be y equals 3. Notice that we are expecting to get the same answer as the one we got using the elimination technique. Okay, now for the Cramer rule, we first recall the formula for a determinant. Okay, we're given with an equation containing two variables. So, what we want is the determinant of a 2 by 2 matrix. This illustration, courtesy of mathsfun.com, will illustrate how more or less we get the determinant of a 2 by 2 matrix. But actually, it's like getting an x stroke or writing an x using the usual stroke. You have here 1 times 4, then minus 2 times 3. Okay, so we're actually subtracting two products. Okay, the first one is the product of 1 and 4, this is stroke here, and then the next one is this product, that is 2 times 3. So the other product becomes a subtrahend. Okay, so take note of the order because subtraction is not commutative. So using Cramer's rule for the two equations, okay, what we want is this equation. So we have to take note of the coefficients of x and y and the constants. Okay, to solve for the d, take note that d is the common denominator in the equation for x and y. To solve for the d, which represents the determinant, it represents the determinant of the matrix formed by these coefficients. We can actually call it the coefficient matrix, okay, coming from the coefficients of x and y. Make sure they are written in their proper order. Okay. What about the numerator? So again, it's the same as finding the determinant of a 2 by 2 matrix, almost same as the coefficient matrix, but the difference is that this column, instead of a1, a2, or the coefficient of x, the variable we're solving for, we're going to replace this by the constants. So c1, c2, c1, c2. Okay. So the difference between x and y, again, they have the same denominator, determinant capital D. Yan, ang ginawa lang dito, yung instead of b1, b2, ni-replace yung column na to by c1, c2. Again, pinangre-replace natin yung constants. Yan, pang-replace siya. Bale, ouch. Okay. Ayun, so let's have the solution of the same equation using Cramer's rule. Okay, so what we want is to come up with the matrix form. Actually, this is the way it's written in linear algebra. Yan, we're coming up with the coefficient matrix. We got this from here, 2, 6, 4, negative 1. So, ayun yung 2, 6, 4, negative 1. Okay, coefficients of x, coefficients of y. These are the constants on this right side. Okay, where we want to solve for x, y, this is actually matrix multiplication. Okay, so to solve for the determinant of the coefficient matrix, what we want is pick this up. And notice the difference of the notation. This is a matrix notation. This is a determinant notation. So we have this product first. That's negative 2 minus the product of that, which is 24. So what we have is negative 2 minus 24. That gives us negative 26. That will be the common denominator in getting the the value of x and y. Again, that will be the denominator in getting the value of x and y. Okay. So, for x, ayan, what happened was, Instead of 2, 6, ito yung column for the coefficients of x. It was replaced by the constants, 13, 0. Again, yung variable na sinasolve natin or the variable we're solving for, yung column niya, yung nire-replace natin by the constants. Okay? So we have 13, 0, and then we preserve the other column. That's for negative 1. So ang divisor natin, again, where did we get this? We got that from the determinant of the coefficient matrix. Okay? So again, using the determinant formula for a 2 by 2 matrix, we have negative 13 there, product, negative 13 minus 0. Negative 13 minus 0, it's negative 13. So just have to copy the negative 26. Simplifying, we have 1 half. Okie dokie. Now let's solve for the y. Okay. This time we're going to replace this column, the y column. That's the variable we're solving for. Okay. We're going to replace that by the constants. Again, yung constants, yun yung pang-replace natin dun sa column ng variable that we're solving for. Okay. So we have 2, 6, and then 13, 0. Okay. Okay, so divisor pa rin is negative 26. Determinant formula, 2 times 0 is 0. 6 times 13 is 78. 0 minus 78 is negative 78. Negative 78 over negative 26, that gives us positive 3. Okay, so the story, no matter what way or what method we choose, whether it's elimination, substitution, or Cramer's rule, we arrive at the answer 1 half 3. So this is the answer or the solution written as an ordered pair, since what we are referring to is the point of intersection of the lines represented by the two given equations. Okay, let's check our answer by substituting 1 half to our x and 3 to our y. So we have for the first equation, 2 times 1 half plus 4 times 3. This gives us 1 plus 12. 1 plus 12 is 13. So check. For the second equation, we have 6 times 1 half minus 3. This is 3 minus 3, and that is 0. So another check. So ayun, so that means we got our answers correctly. Yay! And to end our presentation, eliminate useless anxieties, substitute prayers to your worries. Good day!